Okay, Ed Darty here at Suncoast Technical College, Sarasota, Florida. I attended the Haas Technical Education Center's virtual conference, and I did a presentation on what we learned about the desktop mill with me and Austin Dunk doing some projects at Sarasota High School. For us, we really love the Haas milling machines, mostly because of the control is very easy to use. And as far as limitations of the machine, so this machine is 110 volts. It'll run 15,000 RPM. Has a You have to change tools manually, and your limitation is quarter of an inch or 6 millimeters, about the biggest tool you can get in there. It has the nice door on the top. We were able to cut some plastics in there with no assistance with air, and this machine does not have coolant, so as far as limitations of clogging tools or breaking tools. Um, let's see now. Let me go to my presentation here. So I'm going to have some presentations here under STC share. This is my
Howdy out there.
presentation I did at the conference. I will share that on my on the team site, and a bunch of other fusion videos of how we set it up. And I actually made a model of the vise that we're using in the machine, and some other setup sheets. So something like on this sheet here is what I call my checklists. We have these at all our machines as far as the student or instructor needs to go through this process. We've got it broken down into we have a setup checklist and a run checklist. So we got the vise fixture stock. In other words, you need material and how you're going to hold it, and then go through all those checks. And then we need to set something called a work offset, and then we got to set tool offsets. These are all coordinates that the machine needs in order to navigate its way around. And then we'll have a run checklist. And we typically like to, if you're using CAD CAM like Fusion 360 or a Mastercam, you should be able to simulate in your computer and see pretty much everything that's going to happen. Then when we're at the machine, we utilize the Haas CNC graphics page, and we watch that and make sure that looks correct. Like, first of all, is it the right program? And which is different than running the Techno Da Vinci's, because you really can't see what's going to happen. You're just going to press the button and hope everything's correct. So if you run it in the Haas graphics, you will see pretty much a two-dimensional view of the tool path. The next thing we do is we either run it without material, or we raise the Z coordinate up like 1 inch, and we'll run the part with our hand near the feed hold button and make sure it navigates its way around without crashing into anything. So then we're ready to cut material, and a lot of times you can't see as well. In our machines we have coolant blasting on it, so you can't really see what's happening. But you're pretty confident that everything's going to work out correctly. Now you can just concentrate on sounds and stuff like that. All right, let me get back to, so we have our checklist, we got our CAD CAM capability, which actually helps us out on,
Okay,
like here, this one I have a model of the vise we have set in here. We did a Titan 1M project, and we made this one with one tool, and able to cut most of the material. This is called a first operation, so we're cutting most of it, and the material on the bottom is going to be waste material, so we flip that over and we cut that part off to make it complete. And we talk about tool use and stuff like that. So let's see what else I got here as far as helpers. I'm going to do some videos at Sarasota High to go over step by step how we set up. But I can go over picture by picture while I'm at this right now. Let me go to my desktop mill library. Sarasota High School. Okay, I'll go picture by picture here. Okay, so here's a desktop mill on a cabinet here. Cabinet's closed. The lighting in the machine is pretty good. I would probably add a couple of those puck lights you can get anywhere, because when you open the door, sometimes you need a little additional lighting when you're in there. Of course, this is a safety machine, so when the door's open, it stops moving, and I believe the spindle stops or slows down. If you notice the panel, we got a power on and off button, and we also have a cycle start on and off button. So green buttons I consider to be like the gas pedal. Oh, got the wrong one over here. Green ones are the gas pedal, and the red buttons are like the brake. All right, let me hold up a second here. Okay, I'm back again. So is the setup at Sarasota High School. Let me go on to the next page. This is looking with the door open. We actually made little lines on here of where the machine can go. So it cannot reach all the way into the back. This is your travel limits. All right. This is your handle jog wheel and your cycle start and feed hold button. So gas and brake, think of it that way. The handle jog is for manual movements, and it's actually, every detent is a click. It's not just a wheel. You can roll it like a wheel, but notice it says plus and minus on here as far as which way it goes. It depends on which axes you select, but this is for manual movement. All right, if you notice this one, this is the one off of our machine in our classroom, and the one on the desktop mill did not have the plus or minus button, so we literally put a magic marker plus or minus, so you wouldn't forget which one was which. Okay, this is a panel above the handle jog wheel. We got these multifunctional buttons, and there's some other buttons that say tool offset measure, and disregard the X diameter measure, that's for a lathe. Next tool you won't be using, tool release you won't be using, but part zero set you're going to use. So you're going to use tool offset measure to measure tool length offsets, and part zero set will be capturing the X and Y coordinate for where the part is located on the machine. Alright, this is something called Safe Run, and honestly I didn't try it out. Safe Run is a feature in the newer Haas controls, but we did not test it out to see if it would work on the desktop mill, so we'll update you on that. This is a typical page on the control. This is the G code that runs. Notice it says operation memory, so operation memory means it's ready to run. You hit the green button and it's going to run. Up the top is a program number. This is a format decided by the Fanuc company from Japan, and pretty much everybody follows the same format. It's letter O and 5 digits. Anything in parentheses is considered to be a comment, and it's not read by the machine. So in this case we got machine, date, a tool list, and below that is going to be the set of your G code. Alright, this is the vise we're using. It's from a company, Leading Edge, but we reverse engineered it, and we ought to make some more or modified ones. So we've been mounting it with this in line with the x-axis left to right, but the way this is set up, you can pretty much put a block in there and be able to hold this pretty well, and that's how we use the Titan 1M project. Alright, this is the Titan 1M here, with the material was slightly long, so you want to kind of pay attention to your material size. But when you're dealing with raw material, you want it to be a little bit oversized and let the machine cut everything. The way we have this cut is we're holding on to the bottom, so that in order to make this complete, we flip it over and machine the back off. just like this. All right, this is in the desktop mill. I think I'm using a 3 flute 1/4 inch cutter, and I ran all the operations with this, but I did separate the operations so I could be able to stop and look and make sure everything was correct. This is also with the door open. We were just checking some things out. And right now, this is another check. And preview not available. Okay, this is with machine running with door shut, spindle turning. Another view there, another view there. This was cutting the back off. This would be, we call this operation number 2. And then complete. We didn't set it up to drill holes, so we made what we call a spot face, so where the holes would be. But pretty much complete, other than holes and chamfers. We're trying to devise a way to make a quick change tool holder so we can quickly change tools without having to unclamp and bolt it, because you get tool offsets involved, and that would kind of mess that system up. So for now, we recommend doing projects as one tool only projects. This is like a setup sheet for the Titan 1M. We have our students draw this out, make a solid model, and then do the manufacturer cam side of this. Notice we put some notes up here which buttons we're trying to use. We just actually put some magic marker around the common buttons. Right here it says force, TLM for tool length measurement, PZ for part 0. This is the handle jog, so this makes this work. This will be the increments, so it'll run in 1/10,000th of an inch, 1,000th, or 10,000ths. You can run these in metric mode. We are running in inch, so you can go into the settings and run this totally in metric. But the buttons won't be in metric, so just be aware of that. But it will say on the display what it is. Then down here, this selects the axes. So if you're going to use the handle jog, which you're going to use a lot, you're going to select your increment. Usually I like to use I call it small, medium, large, and extra large, and we deliberately shut off the extra large button because it moves way too fast. We use the large button, and we pick an axis direction and start cranking the wheel, plus or minus, in order to do manual movements. All right, what else we got here? I think I was trying some different photos. And that's complete. That was actually looks like we're making another one. So. And there's Austin with his Titan 1M shirt, and he made his part. And there's me. Okay. This is our vise. So we have it bolted down. We actually modified the vices so it would line up with the T-slots in your table. So this is probably the good position to put it in for now. This is Mr. Dunk doing a tool length measurement setting. So he's got the handle jog wheel using a piece of paper or a shim, and you bring it down. You will be using 1,000th at this point. Don't bother with the 1/10,000th one. It moves way too slow. But we get close. You go 1,000th till you get the little bit of drag on the paper. Once you get that set, you're going to press the TLM button, and that's going to set the coordinate. When you run these machines, when you start them up in the morning, you have to home the machine up with the power restart button. And once it knows where it is, it knows how to get to where it needs to be. Now, as far as the XY coordinate, we'll show you how to do that. This is the Z coordinate, and tools can vary in length, so that's considered to be a separate coordinate system. So you got work offsets, and you got tool offsets, or tool length offsets. So he's setting the tool length offset, which would be the Z axis. And we just tested a aluminum part just to see how it would cut. It did okay. We did some engraving, and we just did a little pocket cut. And this is a like spindle speed is up here. These are, you have active feed rate, that would be active, and right here it says feed rate, override, spindle override, and rapid override. We'll show you how to run those, but in order to run it safely. And this is a Facebook post we did. And also, Shani is actually, she works for Titans of CNC, so we like to put all our Titan of CNC project stuff on there. So they give us a big thumbs up. And this is Mr. Dunk's little coin that they were making, using the same vise with a different work holding system. Okay, so I'm gonna upload all the video content, and let me go back to here again. As far as how to upload a program, that's number one. You want to set your coordinates, X and Y coordinate, with the PZ Part 0 button. And you're going to do tool length offset with your, just like Mr. Dunk did with the shim method. And once you got all those set, you're going to go to memory mode. This row right here is all the mode buttons. And I have some teacher training videos I'll have also on how to run the Haas control. But we usually run the part a little bit in the air, so we'll push the graphics button, which is right here, and we'll watch the screen, make sure it looks correct. And then we'll run the part, run this program with no part in it to make sure it doesn't crash into anything. So you're going to be cycle start to run it. We're going to turn down the rapid rates. These are the override buttons right down here. We're going to turn that down to 5%. And then just keep your finger on the brake. So if anything looks wrong, you hit the brake. And then we can actually look at the coordinate page right up here, and you can see which coordinate is moving next and which way is it going if you're unsure if it's going in the right direction or not. Okay, that's about it for me, so I'll go over this. I'll probably make a more detailed video, but hopefully this will get you started. Okay, talk to you later. Bye-bye.